on this computer. All right. So create a password. I'll go ahead and generate a password, which just does for me. And then what you'll want to do here is basically type in the code I gave you, which is fall 2020 Rosen. Check the box and just hit sign up, and it will bring you to, and that should be either bring you to the course or it will bring you to a different page. So that's all you have to do. So go to, so here I'm just going to go ahead and sign in my account. I will be posting the recorded lectures today as well. I've just been busy just with the first week. So I will post them, and I'll probably post them on the overview page. I will be posting the material for Module 2 later. The Module 2, I can tell you though, right now, that it will be going over, next week I plan on covering all of Chapter 2 and maybe a bit of Chapter 3 because Chapter 3 is very short and Chapter 4 is very short. So, mosquito? So the, so again, if we go over here to assignments, you'll see I've already given you some assignments with some due dates. And today we've got this, do we have to do any pre-readings for the lecture lab? Well, let's see, calendar says 31st, Monday. So have Chapter 2 readings done if you can by Monday. Let's see what that entails. Which is just doing readings for right now. I will be posting exercises that are related to that in a bit. But notice that this is saying reading, so specifically the stuff that you need to read. Now, the way this is going to work, by the way, is that you will have an option. I have been working very hard on creating videos, and I have basically organized them by section. So you can do the reading, or you can watch the video. And if you do watch the video, be sure to actually, you know, go and click through and do the activities in here. But the videos will be another way, will be a different way for you to get this material if the reading is just, if your eyes just glaze over a bunch of stuff like my eyes do online. I can't read stuff online sometimes. All right. So with that being said, we've got project 1. So I'm going to, and if you look here, right, it doesn't really tell you too much. So I'm going to go ahead and click question and context to get to the page. The other way to get to the appropriate project that we're going to start in a second is to click on project 1 right here, which is a preview of the end goal. So, and this is basically, we're going to demonstrate a couple things that you can do in this textbook. And this textbook is very powerful because it has the ability to run Python code in it. Now, a lot of you may be thinking that, oh gosh, there is a lot of advanced stuff here. It looks overwhelming, but that's okay. I don't necessarily believe that you will be able to, like, I don't expect you to basically be able to sit down, you know, and code perfect stuff right off the bat on your second day here. I don't, in the same way, I don't expect you to basically be able to, you know, play an instrument for the first time perfectly. In fact, I will post a couple videos of showing that I am, of me floundering on a trumpet and showing you that what practicing does. So that makes it better. Practice is the way you succeed. Is there a preview of end goal chapter 2? No, preview of the end goal is basically previewing the end goal of the entire thing. What we'll do for chapter 2 is we'll look at driving the turtle and how many handshakes. So we'll be looking at these kind of things. And I will be posting that in the module 2 overview. A lot of things I plan on doing in the lecture. So one of the, so there's a couple things to note about about programming, and specifically working on a program. Your program is an evil genie. It is going to do exactly what you say. Your intent doesn't matter. It is going to do exactly what you say. So if you tell it to overwrite something, it will do it. If you tell it to create 10,000 files rather than one file, it will do that. So that is one thing that becomes very frustrating with programming, but it does become, and you'll find that's tough, but that'll become easier over time. One thing we are going to look at today, though, is basically one of the big skills we learn in computer science, which is to look at something complicated and looks like gibberish, and to pick out things that seem relevant, and basically just kind of try to interpret what appears to be gibberish at the first glance, like this code over here. So you may or may not be able to see what this does, and if you do, great, but if you don't, that's totally what I expect. But this is going to be an example of what you could do at the end of the course by yourself. So let's go ahead and run this and show what happens, which takes this picture, and if you can see via what Zoom is doing, that it's slowly turning this into a black and white picture, right? Now, what this window has is what we call source code in Python. Source code is basically the instructions that we wrote in Python. Specifically, it's got something in what we call a function, which we'll learn how to write much later on. It is, so preview of the end goal is due on the 29th. It's what's said over here. This is basically, I would like you to finish it today, but you could have internet difficulties. You could have some other kind of thing. You could join the class late. So that's why it's due like tomorrow as opposed to the end of class. So we look at this, and let's go ahead and just figure out what this does. This takes in an image, and then it gets the width and height of an image, it says over here. This useful guy over here, and I'll zoom in so you can make it so it's easier to read. This useful guy over here that's preceded by a hash mark is called a comment. The computer doesn't see this. The computer does, all it sees is that it sees this mark and it says, I'm going to ignore everything that comes after it. So it's useful for making comments to anybody else who's going to read this. So what this does is it gets the width and the height, and then for every pixel in the image, what is a pixel? Then, well, if you get really, really close to your computer screen, you might see some squares. Depends on how high resolution your screen is. Each of those squares is a pixel. They have small lights in them, typically, and they are typically of 3 colors: red, green, and blue. So it gets the red value, the green value, and the blue value. And it says if we add them together and divide by 3, and that's, so we basically say if we add them together and divide by 3, and if that's greater than a number, then it sets them all to 255. Otherwise, it sets them to 0. And essentially it says, hey, if they're above one value, make the pixel white. If they're below another value, make them black. So this is essentially a bunch of gibberish. Now look at how this is done. It uses, basically, we define this function, and what it does is that when we define functions, it allows us to use them later. You see, this is what really differentiates basically a programming language from something like a calculator. A programming language gives us the ability to essentially add new verbs to the language, as well as new nouns. We can add new nouns in the ways of variables. We can basically say, hey, store this for me. I want you to remember this. And we can create new verbs, telling the computer to do new things. So we basically get to add to the language that already exists to make it do things that we want it to. So in here, so if you see this window on your side, there's this editor, if you click show code, has a bunch of different functions. In fact, they are numbered. Process 1, process 2, process 3, and so on and so forth. It has 10 different ones of them. Each of them takes in a picture, and what it will do is that it will give us back a transformed image. It will take in a picture, and it's going to play with it some way. A few of these guys take in a second number, so take in a second argument, like over here, process 5 takes in a picture, an IMG, and a number, and that helps it tell it how to do what it needs to do. Now, a lot of you are probably thinking, I don't understand any of this. That's exactly where I want you to be. That's perfectly fine, because that's what we're going to figure out. We are going to figure out how to do these things. Your task is to basically experiment with these functions to find out what they do. You can either use the supplied images. You can use either of these images, either the yawning squirrel or the Luther Bell pic, to use what you want. So let's go ahead and take a look at process 10. So before you try it, you might want to look above here and see what it does. Just see if you can read through it and read the comments and try to figure out what it does. But let's go ahead and try run this. So here I'm taking in the yawning squirrel picture, original. I'm going to run process 10 on it, and then I don't know what this is going to do. New window, new win, image win. I guess win is short for window. So that's going to create a new window, I guess, and then draw that window. Okay. So we save this and we run it, and it's going to run process 10 on the image, which it's doing. Don't know why. Ah, and there it is. Bit surprising, bit shocking, but hey, there you go. This is what our yawning squirrel looks like after we run process 10 on it. I could switch this. So the things you can play with over here are changing which process you're going to run. So let's go ahead and run process 1 on this instead. Okay, so it's running and this is the result of process of image 1. So we see over here, here's image 1, or sorry, here's this one, here's the original, and here's it's changed. Now, now you can go back, by the way, you can change. Now, one great thing about this text editor here is that it does have a history. Whenever you hit save and run, you can go back to anything you changed. So over here is the original. So you can go back to what you did. You can basically, if you completely mess it up, you can like rewind if you need to. So the other thing you can do is you can change it to the other image. So here we have a Luther Bell pic. So I'm just going to copy it rather than type it out. Copy, paste it into here. It's a .jpeg as well. So I'm just going to run that. And so now I can run this again. And it will run process 10, the one that turned the squirrel really evil red, into a different, it will run that process on this picture, which does something really weird and interesting. So your task for the day is to, let's see, I thought I said to do, let's see. It will be random what each of these, but basically what you'll want to do is take each of your 10 processes and match them up to what the effect is. So basically, if you think process 8, it basically rotates this by 90 degrees. What you do is you take process 8, drag it over, and boom. So your job is to match these 10 processes to the 10 different effects. Once we're done with that, we can have a bit more fun. And then when we're done, you'll basically let me know if you were in your comfort zone, a learning zone, or panicking, right? So, and give me your opinion about this. Your grade for this is the grade that you get on this, in case you're curious. Basically, if you get all 10 of these, you get 100. So And you have unlimited attempts, so don't worry about it, but at the same time, be honest. Don't try to like go all permutations. Excellent question in the chat. Is Python case sensitive? Now, for those of you who don't know, case sensitivity means does it care whether it's uppercase or lowercase? And the answer is yes, Python does care whether things are uppercase or lowercase. So for instance, if I try to run process 10 where the process is capitalized, I am going to probably get an error here. So, oh yeah, I did. Down here, it said process 10 is not defined. So, so here what happened is that I made this, it broke on me because I typed in capital P rather than lowercase p. So you want to make sure that basically you keep capitalization. Any questions before we get started on this? Hi, Professor. Can you show us how to do the process with 2 arguments? To pass in a process with 2 arguments, basically, you'll want to experiment with some of those, right? So let's go ahead and take a look at process 6, which takes in a image and it takes in an X scale and a Y scale. In that case, you'll want to give it two values. So maybe giving it with process 6, you'll want to do something like that. So if it takes in that, and then somebody else asked, what is an argument? An argument is something you have when you have a disagreement. Wait, that's not the right context, I think. So are we matching them before running the code? No. You're using the code to figure out how to match them. So you're experimenting and trying to figure out what they are. Basically, you're conducting experiments to figure out which process goes to which effect. Now, what is an argument? An argument is what we put inside of a function, inside the parentheses for a function. So we've been seeing that. So you just make up the numbers. So but let me go ahead and go through. Let me pull up idle for a second. We've seen one function so far in our labs, if you've had a lab. But if you haven't been to lab, we've seen another one with the print function, with the hello world. Print hello, like that. The hello here, the text hello here is what we call the argument. Some functions can take multiple arguments. The print function is one of them. Hello, comma, world. Assuming it can spell. So it takes in multiple arguments. And if you have multiple arguments, they are separated by commas. The arguments don't necessarily have to be strings, by the way. What are strings? That's text. We'll learn more about them in upcoming chapters. But anything that's between quotation marks is text. It is a string. You can also give numbers as arguments. So the main thing here is, now here's the thing. I'm going to split you all up into breakout rooms of a fairly large size. So if you need help, ask. I will jump around and also ask if people need help. And we're going to see how effective this is. We're going to do it for about 15, 20 minutes and see where we're at. Does that sound good to everybody? If you're utterly terrified, you should tell me now. Should you already have Python downloaded? Well, while you should have Python down, it is not necessary for this lab because Python is installed on the server here, on the Runestone Academy server. So you don't need to have Python installed on your computer to do this. All you need is to have Runestone Academy opened and to have an account so that you can get credit for it. Mine is not showing share code. That's okay. It is not okay to use, so share code, that is just for me to share, since I'm the instructor, the share code button is there for me to type something and share it to you. So it's not really relevant. The only one you really need to be able to use is the save and run button. You should not try to do this here you should not try to do this program on your computer, by the way. You should definitely try to do it in the browser. Pair allows you to pair with somebody, but I don't know how to quite use it yet, so ignore it. The only button you should really care about is the save and run, and otherwise this slider over here, which lets you revert. Right? So use the textbook. Any other questions? If I were to hit pair, by the way, it would, I think you would type in the username of the person you'd want to pair with so that you would both have the same code. Is anyone getting a runtime error? Where are you getting a runtime error and why are you getting one? If you generated a runtime error, be sure to see. There you go. So I'm going to go ahead and split you up into breakout rooms, and I'm going to jump so that I can run from one group to another. That way I can address you a bit more and people feel less restrained in asking for help. So breakout rooms will be generated automatically. Okay, so breakout room, we are going to do, let's say, that is a lot of rooms. All right, 13 rooms, and go.
Yeah.
Hello there, room one.
Hello.
So,
number one.
So how many, so questions so far? Are there any, like, is anybody here like completely horrified? Because this isn't meant to be scary. It is meant to be kind of just like a puzzle. Is anybody having trouble like getting started at all, period?
I think most of us were finished, actually.
Mm-hmm.
Really?
Yep.
Yeah.
Yep.
All right. Well,
Well, thanks. Yeah.
Well, if that's the case, there's a second part where you can, well, if you're finished, then there is a second part for you to try, which is basically you can try putting various you can have functions called into functions like this. You can do process 1, process 4, and you can try to combine your effects to see what will happen and see what kind of creative effects you can achieve with this. Because you can see, because what did process 1 do?
It added dark corners.
Yeah.
Well, I mean, see what happens if you basically call process 1 on process 1 calling my image. See what happens there if you haven't done it yet. And if you are still working on this, ask your fellow classmates for help. You're allowed to do that. Okay. So I'm going to go ahead and jump to another room to see if more people need help.
All right, thanks.
Thank you.
Hello there. How are people doing?
Pretty good.
Does anybody need any